Hello and welcome back to the Dragonfly Daily. I am Mike Marsh, the product manager at ORS. You can follow me at Dragonfly Wizard on Twitter. We are back with another episode of the Dragonfly Daily. So if you are new to us, be sure to check out our other videos. You can find them in orss.ca/ytp2. That's the playlist for this and all the other Dragonfly Daily videos. This video is lesson 35. We will see workflows and wizards and reports. If you're watching this on YouTube, hit the subscribe button. If you are interested in watching live webinars, you can find the information in the description down below where you can register and watch these live so that you're able to join in the questions and answers. Now, today's lesson, workflows, wizards, and reports. We will be using Dragonfly 2020.1 Release Candidate 2, and that is available now, or if you're watching this video in the future, then you could just use the production release of Dragonfly 2020.1 or subsequent releases. Now, we're going to talk about some new concepts, some things we haven't looked at before. We're going to talk about the reporting engine and what Dragonfly 2020.1 does for creating reports. And we're also going to talk about how you can enable workflows, or maybe I should say how we enable workflows with our wizards infrastructure. So first, I want to talk about the reports engine. We have been looking at ways to make it easy for you to capture information from your analysis in a standardized and user-friendly way. And so we have prototyped and developed the first version of our reports engine. The idea is that the programmer, or maybe even the user, will be able to customize report templates. These reports would capture scalar values, like if you've done a bone analysis, what is your trabecular thickness? They might capture tables. So if you've done numerous measurements and you want to encode them in a table, they might capture histograms and plots and screenshots, etc. They should be flexible enough to support variable numbers of sections and variable numbers of screenshots. So maybe one time when you're doing a bone analysis, you're doing an anisotropy measurement, so you may want to have a section on anisotropy, but another time you may only be doing trabecular thickness and trabecular spacing, so you shouldn't see the anisotropy section. So the reporting engine should be flexible enough that sometimes when you run the report, you want to capture some types of results and other times other types of results. So the idea is to have a report template. So on the right, you see an example of the output of an example report of the reporting engine. Now we'll talk a little bit more about it. The way we do this in Dragonfly is we use an XML data structure to make this as flexible and extensible as possible. And the XML data structure is a file format that allows us to encode and capture the data that you want in a report, but it also is a data structure that can be used and edited, and it can be programmed too. So if you follow this diagram, Dragonfly extensions and plugins will be capable of producing an XML data structure that encodes what you want in the report, those data, those screenshots, etc. Then you can take an XML report and theoretically you could do an infinite number of things with it. So what we are doing in this first version of our reporting engine, that is what we're doing in Dragonfly 2020.1, is we are implementing this arrow. So Dragonfly 2020.1 is giving you the framework for generating XMLs and then transcoding the XML into a PDF. So there is something called an XML style sheet transform. I don't know what the L stands for. I can't remember. So there is the XSLT transform that allows you to take an XML and encode it into a PDF. The flexibility of this is Dragonfly can write XML reports using custom code, and you may generate dozens or hundreds of reports over the months, and then you can always transcode those to a PDF. The user could at some point later say, well, I don't like the format of our reports. Then rather than having to regenerate all of the data, you would just change the style sheet. So you would change the style sheet lookup transform, or whatever the L is. You would change the XSLT so that you could then reprocess all of those XMLs into new reports with the new form. So that's the beauty of encoding it in XML. That is not designed to be human consumable, but you can change this so that you can change the format that it is consumed in by humans. But this is highly extensible if you are working in part of an enterprise group that captures lots of, oops, what is that? Trying to respond to the chat window, and extensible style sheet language transforms. Thank you, Matthew. So extensible style sheet language transforms. So we are giving you the flexibility of creating a PDF. However, if you're working in some sort of enterprise environment where you need to extract all the information from all of your different studies and encode them in your database, you could write your own code that transcodes XMLs into your database. You could generate an HTML website that has all of your reports available as HTML pages. Anything is really possible if you want to write code to access XML. Now, the idea in this first version is you create a report from a single data set, and then you create a PDF report from that XML report. You can imagine a solution where instead of running on a single Dragonfly workstation, you may be running on dozens of HPC nodes or Amazon EC2, where you're working on lots of data, and then each time you run a particular workflow, it generates an XML report. You can further imagine the idea that if I'm doing a study and I'm doing hundreds of bones or hundreds of rock plugs, I may wish to not just capture a report on one, but I may wish to capture a report on dozens, and then write my own code to write aggregate reports. So I had a user who says, well, what if I want to know the trabecular thickness spread? If I compute trabecular thickness on bone 1, bone 2, bone 3, bone 500, that's great if it's in one report, but what if I want to see a histogram or a distribution? Then you would need to interrogate a collection of reports. So this is something that users could do in the future, is program or write their own style sheet transforms or other codes to transcode a stack of XML reports into an end report. All right, I think that's all of the slides that we'll go through for today. Now I'm going to pop over to Dragonfly. In Dragonfly, in version 2020.1, you will find under Utilities a tool called Report Generator. This is a very simple tool for now. All it does is has this one button where you can specify an XML file, you can specify an XSLT transform, you can input any key information about the particular report, and then put the report file name, and it will generate the report. Now the idea here is this is after you have already generated all of the data to be encoded in the report. That is all of the results that will be captured in the XML file. Now we're not going to need to use this because I'm going to show you, sorry, I thought I had captions on. Too bad. Or on now. There we are. Now we can, we're not going to actually need to use this report generator. We're actually going to, let's close this. We're actually going to show you what bone analysis looks like in and where it invokes the report generator. So what I'm going to do is I'm going to open my organizer and I'm going to pull up the bone data. This is the same bone we looked at maybe a couple of days ago. This comes from Carl Jepsen and Rob Goulet at the Orthopedic Research Laboratory at the University of Michigan. So thank you for this mouse femur. And what I'm going to do is show you in Dragonfly how when you want to generate reports, you might take advantage of wizards, which walk you through particular workflows. You will find under workflows, you'll find different tools over here, but particularly when you right-click on a bone sample or when you right-click on an image channel, you'll see Bone Analysis Wizard and Segmentation Wizard. If you have the license and Plug Analysis Wizard is available, you'll see Plug Analysis Wizard. Anything else that we develop as well as we will support third-party development of wizards. So a wizard is a multi-step workflow designed to guide you through a series of actions to compute some sort of analysis. So I'm going to choose Bone Analysis Wizard. This is going to take me into a new context. I'm going to see if I can change the screen size so that we can still see the captions on the bottom of the screen. Okay, here I am in this window, which is the wizard for bone segmentation. And what you will see is I have limited access, so I do have multiple views right now, and over on the left I have a main tab and a segment tab, but above all of that I have step 1. So this says segment the bone image, fill the bone segmentation. So we're going to create a segmentation. It's actually created an ROI for us. So we're going to follow these steps, and in the upper left, it tells you what step we are on right now. In the lower right, we can restart the wizard, or we can advance to the next step or retreat to the previous step. Now, here what we'll do is we'll use some of the tools we know about. So I'm going to use define, range, upper O2. Now, we have a whole host of tools, and you have access to most of these ROI tools and ROI Painter if you want to paint and do segmentation here. Now, I'm just going to take all of this, and I'm going to use ROI tools, and I'm going to add it to the selected bone ROI. Now, that was the first part of step 1. We also need to fill in any gaps here. So if I look through here, if I had vasculature gaps where there are holes in the surface of the bone, then I would need to fill those. So we'll also see that there are gaps right here. Now I could use the ruler and measure the gap in microns and then put that value here. What are the smallest, or what are the largest holes that you need to fill? So if you had holes like this that went all the way to the surface, the workflow is going to depend on knowing the size of those holes in order to close the gaps. So we're going through a bone analysis workflow that's prompting us what to do next. Now I'm going to leave this value 150 microns and I'm going to hit fill. Now there's a multi-step operation. I think we'll only look at this blue progress bar for maybe 30 to 45 seconds, I think, on this computer. So we'll let that go. Now, what it is doing is it's doing a series of operations. It's actually telling you a little bit about what it's doing. We could document this for you if you like, but we are doing some distance map operations and then I think some closing operations and some hole fill operations. It's very, very similar to the close holes smaller than. In fact, it may be exactly the same as the close holes smaller than that you see when you right click on an ROI. Okay, involves a couple of distance transforms. And then it evaluates those, it does some thresholding on those, and we end up with a filled in image. I think after actually it evaluates the closed holes smaller, it actually runs a fill using the fill inside, fill 3D, which you see over here on fill inner areas. So I guess I was wrong about the 30 to 45 seconds, but we're already on step 7 of 7, so it's done. I saw the last thing it did was fill inner holes. Now in my workspace over here, you see I have bone ROI and I have bone ROI filled. If I look at it, we can see that it's filled in. Now it has some logic, so I'm going to change the color on this. So it has some logic. You can see that it did not try and process this over here. It just took the single largest ROI object that we had in our initial ROI, and then it proceeded to do the filling operation. So that was all of step 1. And for user input, all we did was create an initial segmentation. If we already had a segmentation, we could use it. So we just created an initial segmentation in this case by thresholding with upper Otsu, and then we click the fill button. Now we can click the next button and we'll advance to step 2 of the workflow. Step 2, segmentation of the filled bone as cortical and trabecular. So with the next step before we can do any microstructure analysis on cortical bone properties or trabecular bone properties, the next step would be separating the bone segmentation into cortical and trabecular. Now over here we see there are 2 different methods available to us with a button called segment. We have the Bowie method, which is described by this paper from Bowie and colleagues in 2007, published in Bone. We also have the Kohler method. So all my team has done here is read the paper, read the algorithm, and then implement it in Dragonfly in this wizard. Now what I can do here is I can set the trabecular thickness, so you can look at the thickness of the trabecular struts that you're trying to segment. I'm just going to input the value 55 and hit segment. So this is going to go through the algorithm described in Bowie et al., which involves some dilations and some closings and some hole fills. It's all spelled out in this nice diagram in that paper. I wish I had that paper in front of me so we could look at it. But remember, in some of my earlier segmentation lessons, I said there's this rich toolkit of mathematical morphology operations such as opening and closing and dilate and erode. And what the authors in this paper did is they put together those tools in a very useful way to help identify which pixels should be labeled as cortical and which pixels should be labeled as trabecular. All right. While that is moving, I do want to draw your attention to some of what you can do with bone analysis in Dragonfly. So I'm going to go over to the Dragonfly landing page. This is the objects.com/dragonfly. From this page, you can go to Features, Bone Analysis, and you'll see here discussion of what you can do in bone analysis. On the right-hand side, you'll see the bone analysis data sheet, which just summarizes some of the things you can do, and it lists some of the measurements you can make, such as trabecular thickness or trabecular spacing. So you'll see you can do total volume, BVTV, you can do average marrow area, etc. You can also make slice-wise measurements. So that's all defined on the bone analysis data sheet. You'll also see these 2 technology notes, and these describe sort of what we do when we use some of these tools in application to, in this case, a very large micro CT scan of 130 gigabyte scan of a sheep femur provided by the workers at Tescan in their micro CT product line, the XRE systems. They're headquartered in Ghent, so thank you to our collaborators there. You can check out these technology notes. This is on Dragonfly bone analysis. This one is on morphological and shape measurements. But then if you dig into this one, it will discuss anisotropy measurements and mapping measurements. So if you want to understand the anisotropy of your trabecular bone and visualize it and quantify it. It shows you how to accomplish those measurements on any particular region of bone, so you don't obviously need to run it in areas where there's no trabecular lattice. And, stupid Slack. There's always something going on. And quit. Okay. And now, besides mapping trabecular structure, you can also map BVTV. So if you want to see areas that have high bone volume fraction or low bone volume fraction, that can be mapped. So those are some of the things that you can do, and you can read more about that by clicking on these notes here on the bone analysis page. Now I'm going to go back to Dragonfly, and I do need to go into the window that's showing my bone analysis context. So if we look here, we now have a cortical bone and we have trabecular bone. Now I'm going to make these colors a little higher contrast. And we see that we have an initial segmentation of the trabecular bone. Now, if we're satisfied with this, we could move on to the next page. So the first page was defining the filled bone ROI. The second page is segmenting trabecular from cortical. If you had done this independently, you could always just import those. And in the next step, when it says, show me your cortical bone, you don't have to use the one generated by the wizard. You could use one generated by your own methods. So I can click next, go to the next step. This is step 3, global measurements. So it is going to need to know the filled bone ROI, the cortical bone ROI, and the trabecular bone ROI. Here are a list of measurements you can compute. Now I don't want to compute these anisotropy measurements. They're going to take way too long to do during the duration of this webinar. In fact, all I'm going to do is compute trabecular thickness and BVTV, nothing really advanced here. And I said trabecular thickness, so we'll make it trabecular thickness. Now, I select all the measurements I want, and I hit Compute Measurements. It will go through and compute all these measurements, and it says, okay, the trabecular thickness might take a while because it's going to compute over the entire image rather than my giving it some subvolume to compute. And I say, sure, go ahead. Once it computes these, it will populate this table with those measurements. You'll be able to see what value was derived for those global measurements. All right. The Step 3 that we're on right now is the global measurements. We'll also see a step 4 for doing some of the anisotropy and mapping measurements. Instead of giving us a single scalar global value or a single global measurement that is a single scalar value, we can do those mapping measurements. And that's what we'll see in the next step. Now, at this point, we have computed these measurements, and we can advance to the next step. So that was step 3. Now we're in step 4. Where I can compute scalar and vector fields. Now I can always retreat a step, or I can go to the next step. We're not going to do this today. Now if you want to learn more about this, you can check out those data sheets I was referring you to a few minutes ago. Now after we go through step 4, step 5 is generate the report. And we might have a project title, like let's say I have been doing a drug treatment study on drug X, and I am analyzing 100 mouse femurs to see their response to drug X. And so I want to say this is the drug X study, and I say this is control bone number 33, and we could maybe there's a job ID, or maybe there's a bone identifier, so we can call this bone 33. And we can describe what we're trying to do here. This is my bone analysis of bone 33 for the drug X study. Please see protocol X, etc., etc., etc. So you can put whatever you want in here. These are just notes that can appear in the report. Every report does take, as a default anyway, some authoring information. So this is what will be used to populate the report, at least with the report templates that we've built. You can also browse the disk for a small PNG or an image that you would want to appear as your logo to appear at the top. Now, once you've populated this, you can hit generate. Now, I'm not going to do that right now because I think there's an issue in this build, but I will show you the sort of thing that you get when you generate the report. Oh, you know what? Before I do that, there's something else I want to mention. So while I'm in this context, you can at any time create screenshots and snapshots. So if I look over here on the left, I have the multiple screenshots panel. And if we take a closer look at the multiple screenshots panel, I might say, well, I'm interested in this screenshot, so I drag it over here. And I might be interested in this screenshot, so I drag it over here. And what I can do is I can define image metadata. So I can take this particular screenshot and say, this is the, I don't know, proximal femur trabecular structure, and caption note the trabecular structure, unexpected, something, 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 and you can put whatever notes you want in here and click OK. Now you can do this on all of the different screenshots, and you can create as many screenshots as you want. When you generate the report, it will include a section on the screenshots. So if we come over and we look at an example report, here is a PDF that has been generated using a reporting engine. So we see the graphical logo at the top. We see a title, a project name, a job ID, the date, and the authorship. Then we see the global measurements for the bone encoded in a table like this. Now, all of the information you care about is encoded in the XML file. This PDF is the result of a template that my colleagues have developed for what to use when transcoding the XML into a PDF. You could completely refactor how this looks. We're really using the LaTeX report generation engine to accomplish this. And really, you could do anything that you could do in LaTeX could basically be accomplished here. And so if you don't like this format, don't worry. This is something that can be completely customized later just by modifying the XSLT transform that generates the report. What's key is the wizard itself captures the reporting information, including the screenshots that can later be transcoded. So section 1 is global measurements. If I scroll down, I see section 2, snapshots. Someone made a snapshot called general appearance and wrote up the text description and then wrote up a figure caption. Someone also made one called femoral head in 2D. And of course, your screenshots capture whatever is on screen, which might be the background or the screen overlays or the measurements. So this is how you would encode different screenshots and different details into your report. So the idea is you generate an XML report with the reporting engine, and then the XML report can be transcoded to a PDF or something else. If you want to see what the XML report itself looks like, it's an XML file, it's human readable. All of the data are here, and there are references to the different screenshots that appear. So all of this can be easily mined by any other program. If you have 20 of these reports and you want to go find the trabecular thickness in every one of them, then you can look for the measurement name average trabecular thickness, grab the measurement value, and then of course you could go about creating a new histogram with all of those values. So that gives you the framework that we're trying to describe today. The idea of using a wizard to guide you through a workflow and then do a report. Now, these two are coupled in this instance. We are using the wizard to populate what goes into the report. They do not have to be coupled. So as a user, if you want to write your own workflow and you don't want to use the constraints of a wizard, that's fine. You can always write your own tool for writing an XML file, and you can make it interactive, or it can interrogate the existing objects, or you can make users drag and drop ROIs onto the report object. You could make any sort of reporting plugin you want. And then, of course, at any time, you could take the XML file, save it to disk, and then you could at any time transcode the XML file to a PDF or something else. So I do want to repeat that in this framework, what we're doing today is rolling out the reports engine and the capability of Dragonfly to generate XML files and then transcode those to PDFs. Once you have this file, then users can write their own code, or you could make requests for us. Maybe we should build something where you can take all of your reports and aggregate them into HTML pages, because that may be a better way of consuming than the PDFs. So this should be brand new for all of you. I don't think any of you have heard about this. So let's see what you have for questions and answers. All right, I do have 2 questions popped up in my dialogue. One is, can you put the captions back on? So sorry, those went away. They're done. Next question. All right, so this is a question going back to yesterday's content on Segmentation Wizard. How best to train a deep learning model in Segmentation Wizard across multiple volumes? I've been creating a new context for each dataset and reloading my saved deep learning models. This has been crashing Dragonfly, specifically when I try to train, as it loads its random forest ML models after training the convolutional neural network. So if you can, please send us the crash report. So this looks like a test case we would not have looked at, trying to create multiple segmentation wizards and all using the same models. It might be that there's some conflicting information where they're trying to access the same model. It may not be capable of doing that across different wizards. Now, I think the short answer is what you want to do here is not in the scope of what the segmentation wizard is designed to do. So the segmentation wizard is designed to take that use case of, I need to generate training data and I want Dragonfly's help so that I can train an easy model, or so that I can easily train a model. If you already have multiple data sets and you have multiple inputs or just training data from slices on different images, then that doesn't fit in the spec or the scope of deep learning of the segmentation wizard. You can go back to the deep learning tool that we showed in 4.1 and we showed in earlier lesson. The segmentation wizard is designed for that use case that's probably 90 to 95% of users who have one input. The next question is, can you use the report generation with any data, or is it restricted to certain applications? So the reporting engine right now, we've only written code for bone analysis and plug analysis. We'll be releasing documentation showing you how to write your own reporting tools with customized extensions. But for now, the only XMLs that Dragonfly generates and the only XML style sheet transforms that we supply are for the bone analysis and the plug analysis prototype we've built. So if you have other applications that you think that we should develop, then you could type them right now. And if you are already developing your own code and you want us to have a special webinar on how to write your own reporting engine in Dragonfly so you can write your own custom extensions and then share them with others, then we're happy to provide that. Other questions on reports or on wizards? While I'm waiting on you guys to ask questions, let me do this once more. I want to know how many of you that are listening right now, I asked this question at the beginning before we started, but I'm going to ask it again. How many of you right now work on porous samples that have pores in them, and you start with data sets that are cylindrically shaped? So how many of you work with something, maybe you drill a plug out of bone or rock or something like that? Raise your hand if that is you. You work on porous sample that starts with a cylinder shape. Okay, so it looks like we've got 17 or more. You can keep your hands up so I'll know in total how many of you there are. So this is a popular workflow, and in addition to bone, it's another common thing that people try and do. They try and characterize porous media. That is the subject of the plug analysis wizard that we have prototyped. So I would like to propose a meeting. I will email everyone on the Dragonfly Daily distribution list and announce a meeting probably about a week from now to get user feedback on what you want a plug analysis wizard to tell you. Do you want it to tell you porosity? Do you want it to tell you, I know you want lots of things that we don't do. I know you want permeability and you want other numerical modeling, but for the things that you know you could do in Dragonfly, what would you like a plug analysis wizard to automate and make a routine? And then what data or results or screenshots? Because I didn't mention this today, but screenshots could be automatically captured as part of the report. Maybe I need a 3D rendering with a cutaway, and maybe I need an axial view and a longitudinal view, or maybe I need 10 axial views spread throughout the sample so I can visualize how the sample is changing. You can imagine all sorts of things. Okay, so stay tuned while I announce that, so a meeting on that topic. Here is a question. If we can use the report function that includes parts of multi-ROI analysis result in additional to screenshots, that would be useful for general purpose. Well, that's a good question. So let's say you had a multi-ROI and you wanted to generate a multi-ROI report. What would you see in that report? You might want a volume distribution of your different ROIs, or you might want to know, well, maybe whatever measurements you've computed, maybe there could be a general template for generating that to report and generating certain screenshots. So that's worth discussing further. I'd like to hear some more detailed proposals there. Here's a question. I wish I could apply simple shapes to the analysis I need to make. That would get rid of one variable. Simple shapes to the analysis. Well, I'm not quite sure I know what you want to do. So you have the shapes framework for putting shapes in Dragonfly. You'll have to use more words and tell me what analyses you're trying to do, or feel free to set up a call with me if you want. All right. Any other questions about reports or any other suggestions you want to make about what you'd like to see in reports? Okay, here's a question. Would it be possible to access the content of the Bone workgroup from yesterday on YouTube? I couldn't attend. I'm sorry, Fatima, we're not going to be publishing that on YouTube, but the short version is send an email to me today and we'll make sure that you're on the list. Maybe you're already on the list. We will be sending out a document in the next 24 hours telling people what they can do if they choose to agree with the collaboration, what their commitment is, and what the scope of the project is. And that will be a document that you can share with your principal investigator if you're not the PI making the decision. And then we'll, within a week, determine who is signed on, and we'll have a follow-up meeting and move forward with that collaboration. Okay, any other questions for today? All right, well, thank you for your attention, and we'll be back tomorrow, I guess, to talk about CT reconstruction. So, all right, everyone, take care, have a good day, and we'll see you tomorrow.